Today, we're going to learn about solving systems of inequalities. Just like the last chapter where we graphed one inequality, now we're going to graph two of them to make a system and see where the two graphs overlap. First thing we need to do is solve both equations for y. With the two equations we have, we need to take the first equation and solve it for y. And we're going to do that by subtracting 2x to both sides, which gives us negative y is greater than or equal to negative 2x minus 3. Then we'll divide by negative 1 to everything, and y is now going to be less than or equal to 2x plus 3. Now remember, anytime we divide by a negative, we have to flip that inequality sign. The second equation is already solved for y. Now we're ready for step 2, which is to graph both inequalities. Do our first one in green. The y-intercept is positive 3 with a slope of 2, so we'll go up 2 and right 1, and down 2 and left 1 a couple of times. Then, since it's less than or equal to, we'll use a solid line, and less than tells us to shade everything below the line. We can graph the second inequality in blue. We have a slope of positive 1 and negative 1/2 of the slope. So down 1 and right 2, and up 1 and left 2. Since it's greater than or equal to, we will use another solid line, and greater than tells us to shade above. Now we're ready for step number 3, which is to look for the overlapping region. We can see the blue and the green overlap right here, and this gives us all of our solution area. But to make sure that we've done this correctly, we need to pick a point within the solution area and plug it back into the original equations. Make it easy on yourself and pick a point with small number values, such as the point 1, 1 right here. We'll take both of the original equations and replace the x value with 1 and the y value with 1. That will give us 2 times 1 minus 1 is greater than or equal to negative 3. Well, 2 minus 1 is going to give us negative 1, which is greater than negative 3. That one checks out. Replace it in the second equation. We'll have 1 is greater than or equal to negative 1/2 times 1 plus 1. So 1 is greater than or equal to 1/2, which is also a true statement. So we can be confident that we have found the correct solution region. In the next example, there's no slopes, meaning we're going to have horizontal and vertical lines. First one, x is greater than 5, means we have to go through the x value of 5 and only that one, which will give a vertical line. Then, since it's just greater than, we're going to use a dashed line, and we can shade everything above 5, which will be to the right. Then for y is less than negative 3, we need to go only through negative 3 on the y-axis, which produces a horizontal line that is also dashed since it's just less than. And we will shade everything below. Again, we're going to look for that overlapping region, and here is our solution area. Then we can pick a test point, such as 6, negative 4. If we test that, we'll have 6. Testing that will give you 6 is greater than 5, which is true, and negative 4 is less than negative 3, which is also true. In the next example, we have both a linear and an absolute value equation. The first one is linear and has a y-intercept of 0. Then a slope of negative 3/4, so down 3 and right 4, and up 3 and left 4. Then, since it is less than or equal to, we'll use a solid line again, and we can shade everything below the line. The second equation is an absolute value, and remember these are our V-shaped graphs. We first need to find the vertex, which will be a positive 1 since we changed the inside number, and 0 for y. Then we really have a slope of 1 on the outside, which will tell us how much to go up and over. Starting at 1, 0, we go up 1 over 1 to the right, and up 1 over 1 to the left, connected again with a solid line, and there we have the absolute value function. Then it is greater than or equal to, so we can shade everything above our graph. Now you might be wondering, there is no overlapping region. What does that mean? If there is no overlapping region, then there is simply no solution to the problem. Go ahead, pause the video, and give this one a try on your own. On this example, you should have all dashed lines. You should have one linear and one is an absolute value with a vertex of -2, 0, and a slope of 2. You're going to find there's just a small solution region right here. You can pick a test point like -2, 1, plug them both in, and you do get 2 true statements, so you found the correct solution region. Now we're ready for some word problems. Benji's shopping for notebooks for school. He can choose between spiral notebooks that cost $2 and a 3-ring notebook which costs $5. He needs at least 6 notebooks. The cost of the notebooks can't be more than $20. First, we need to write a system of inequalities to model the situation. We need to ask ourselves what the goal of each equation is. For the first one, we know he needs to buy at least 6 notebooks. Let's call the spiral notebooks X, and then the 3-ring notebooks will be Y. So we know that we buy spiral notebooks plus 3-ring notebooks, and those are at least 6, meaning it's greater than or equal to 6. Then we know the cost of the notebooks cannot be more than $20. Well, we find the cost by taking the variable and multiplying it by how much each one cost. Since spiral notebooks are $2, we'll have 2x, and then 3-ring notebooks are $5, so we'll have 5y. It cannot be more than 20, so it has to be less than or equal to 20. Now, before we graph and solve the system, we need to make sure that we solve both of these equations for y. For the top one, we'll just subtract x to both sides, and y will be greater than or equal to -x plus 6. And for the second one, we'll subtract 2x to both sides, and 5y is less than or equal to -2x plus 20. Divide everything by 5. And y is less than or equal to -2/5 x plus 4. Now we're ready to graph both of our equations to solve this system. Sorry, I forgot to put a graph in your notes. Go ahead and draw a quick copy like the one on the screen. The first equation has a y-intercept of +6 with a -1 slope, so down 1 and to the right each time. Then, since it's greater than or equal to, we'll use a solid line. Then we'll shade everything that comes above the graph. The second one has a y-intercept of +4, and then we'll drop 2 and run 5 for the slope. It also is less than or equal to, so we'll use a solid line. And with less than, we're going to shade everything below. Then, to find our solution region, we need to look for where it's overlapping, which will be this little sliver right here. This means any combination of spiral and 3-ring notebooks found within this black area would produce values that make this system true.